Hello and welcome to our special 10-hour celebration. Thank you for the sub, Apita. Welcome to our special 10-hour celebration of the 365 Days of Astronomy podcast. Our little show launched on January 1, 2009 as the official daily podcast of the International Year of Astronomy. Well, somewhere along the lines, 365 days was not enough. And over a decade, we have continued to bring you new content every day. But it's not just me and my team, it's the entire global community of astronomers and astronomy lovers. Today, we are going to bring you guest after guest as we celebrate what we've accomplished, and we are inviting you to be part of all of it. We will have numerous giveaways throughout the day. Binary Ablaze is right here with me in my attic to help you get those all sent out. We also have Susie out in the chat coming to us from Atlanta and running the giveaway system. And you don't have to buy anything to be able to enter the giveaways. You earn tickets just by watching. So stay on, and you have the potential to win t-shirts, books from the authors that we have joining us today, and so much more. Now, we also are going to be doing much silliness that will cost you money. If you want to sponsor an episode, you can pick a day, and for $45, either through Patreon or through our sponsorship form. Thank you so much. I have two different sets of messages up. Thank you so much for that duplicated message that I will have to figure out what was. We will record a message sponsoring a day, and the first 50 people who sponsor a day today will get a free 365 Days of Astronomy t-shirt. Now, the real reason that we're here today is not to raise money, although raising money does allow our show to keep going, so please consider giving. The real reason that we're here today is to celebrate all the people who made this show possible. The first person that I have joining us today is Dr. Jay Pasachoff. He is coming to us from Massachusetts, and he has been with us since year one. Welcome, Jay. How are you doing this morning?
Just fine. It's very nice to be with you, and I've enjoyed regularly appearing on 365 Days in Astronomy and now CosmoQuest.
Now, you've been with us since 2009. What was it that got you to thinking, I can teach the world about solar eclipses using audio files?
The solar eclipses are just the most exciting things, and they cover thousands of miles across whenever there is an eclipse. So I figured by notifying the people in all the different countries around the world where they might see an eclipse, we get them to pay attention to something interesting, something scientific. And we found that once we get their attention, they pay attention to all kinds of scientific things and not just the eclipses.
Now, well, you are not Mr. Eclipse, because that moniker actually belongs to somebody else. You are basically another version of Mr. Eclipse. You are part of the International Astronomical Union Eclipse Working Group. You are working with Division C, the education part of the IAU, to spread the word of eclipses. And this is part of the research that you've done over the years, isn't it?
Well, I was wondering for many decades why I was offered a job at Williams College, which is a liberal arts college in New York. For those of you who don't know, one of the top colleges in the country, but with people who care about teaching in addition to research. And why did the chairman of the Harvard department, where I had graduated almost 3 years earlier, think of me? And I figured out that I had just done some work with students while a graduate student. I had paid some attention to the undergraduates. And I've always been interested in teaching and spreading the good word about the wonderful things we do in astronomy.
Now, where were you when you saw your first total solar eclipse?
Well, as it happens, Harvard, which is famous for the professors not having a lot to do with the undergraduates, was starting a new program back in 1959 where the senior professors had a freshman seminar each,
Uh-huh.
or some of them. And one of them was given by the director of the Harvard College Observatory, Donald Menzel, who was well known for studying the sun at eclipses. So I was taking his freshman seminar. I had been interested in astronomy through probably the Hayden Planetarium in New York before then. And it just turned out there was a total solar eclipse that crossed near Massachusetts just 2 weeks after the semester started. He borrowed a plane, a DC-3, and took the class, the dozen of us, up in the plane to see the eclipse. And that was my very first one. And now I've seen 34 total eclipses.
That's awesome. And I want to point out Mike Cassidy in the chat just mentioned that he wrote your wiki page. So I think that's just an awesome confluence of things. This
Well,
particular.
thank you, Mike. I'll have to look at that.
Now, I for one have tried many times to view solar eclipses. I attract clouds. It's my very special feature. We all have horror stories and good stories. Can you tell us first the worst experience you've ever had trying to chase down a solar eclipse, and then the most remarkable science moment that you had chasing down a solar eclipse?
Well, I guess I don't really chase eclipses. I don't like that term, eclipse chaser. I'm an eclipse proceeder.
Okay.
And I use 20 years of satellite views of the Earth that have been put together by my friend and colleague Jay Anderson, a Canadian meteorologist. And I take my expedition to a place where it's accessible, but also where the weather statistics are very favorable.
Okay.
So I've really had a very good record on seeing the eclipses. I give up seconds of totality, for example, for logistics or for the weather statistics. So that's really been very good. As far as the most interesting scientific one, well, it's usually the latest one because there's always something new with each eclipse. We're in a different phase of the sunspot cycle.
Yeah.
Sometimes there are big eruptions. If we get to my slides, I'll show you an eclipse from 4 years ago where there were just 2 coronal mass ejections going off to the sides. And when one of those hits the Earth, it could knock out satellites and do a lot of damage to Earth's communications. So there's just something new all the time.
So I will have your slides up in just a moment. I'm putting the final finishing touches on getting them laid out. Thank you for your patience. Okay, so which slide would you like to start with?
Well, we can start at the beginning, and I guess since I'm looking at the screen, I guess I'm a few seconds behind on the screen.
Yes.
But on the screen, not only my name and location, but also some summary of the phases of an eclipse. So
yes, so that one is currently up for our audience to see.
And one of the things that I try to point out is that the view with the partial phases, which use those glasses, which people call eclipse glasses, I like to call them partial eclipse glasses to emphasize that during the total phase, you take them away and there's just this most dazzling stuff. Let's see the next slide, which gives more of the total eclipse phases without the glasses, and it just gets 1,000,000 times darker all around. So the stars come out, and we're now celebrating the 100th anniversary of Sir Arthur Eddington testing Einstein's theory of relativity at the 1919 eclipse because he could view stars near the sun in the middle of the day. And as you know, Einstein's theory has passed a whole lot of tests over the last 100 years, including these new gravitational waves and giant black holes that we've been hearing about. This dazzling, the second of the features is the diamond ring effect, where there's just a little bit of everyday sunshine still showing through a valley on the edge of the moon. And only recently has NASA and the Japanese Space Agency mapped the moon accurately enough that we can really predict that very accurately. And we've been studying the size of the sun, for example, using these new capabilities. You may as well advance a slide or so. Maybe you
Okay.
already are. Why don't you advance a slide every 15 seconds or so?
Okay, so I skipped over the ones with text, and we're on
We're
the
doing.
2013 photo
Um,
with the corona and the pink around the horizon.
yes, I can see what that is. Do you have the do you have the one from Edmund Halley? And there's an old map from 1715 I had a slide of.
Yes. Okay, so I've gone back to that.
Okay. So he was the first to draw a map with the accurate predictions, and he was a few miles off and a few seconds off. But then they fixed that up. So we've keep improving. But the 1715 by Halley was the first one, and then the next one is a map of where some of the eclipses were. And I was going to show a picture from Gabon, which is very near where Eddington did his experiments 100 years ago. And if you look at that big picture of the sun with the red around the rim, that's a composite image made of a few dozen pieces of the best parts, because the corona actually falls off very rapidly in brightness from the edge of the sun. But you can see the bright chromosphere, the chromos color, which is just being covered by the moon when this picture was taken. The slide used was taken, but you can see those big eruptions going off to the left and to the right, and so the sun governs the whole region of the solar system. In fact, NASA has started calling it the heliosphere instead of the solar sphere. It's heliophysics instead of solar physics that we're talking about. So you get to see
Now,
this beautiful stuff dramatically in the sky if you're there in an eclipse. Why don't you go to the next slide?
well, so one question. While we have this amazing image of
Yeah.
the corona up, this really starts to get at the heart of why we still study solar eclipses rather than just enjoying them. What we're able to see during the eclipse, we can't see with spacecraft, we can't see with ground-based telescopes. Can you explain this effect and this problem that requires us to still seek out solar eclipses to gain scientific perspective on our sun?
Sure. And the next slide may show that a little better, because the next slide is a composite that shows a big donut around the everyday surface of the sun. And that's what you can't see from space, and what we need eclipses to see. So the corona is the outer part of the sun's atmosphere, and it's gas at millions of degrees that we have trouble studying on Earth. And there are billions and trillions of other stars that have coronas like this, but only for the sun can we study it in detail and see how it really interacts with other parts of the sun. So only on the days of eclipses that occur about every 18 months or so from the Earth, if you're in that path, then can we get a complete picture of the sun. So we're trying to get a complete picture of the sun to study all the stars, and especially the stars of that whole temperature range that the solar atmosphere is in, which is kind of average for the sun. There are a lot of hotter stars, a lot of cooler stars. But again, there are billions and trillions of these sun-like stars, and we're studying a typical one, and the one we have as a astrophysical laboratory right close to us, only 8 minutes of light travel time away.
Now, I'm going to skip ahead, and one of the things that you have a slide on is the sunspot cycle. And I'd love to know just what is the variation that you've seen over your lifetime with the sunspots and the eclipses and the activity level of the corona that you're only able to see during these eclipses?
Sure. Well, you were kind enough to ask when my first eclipse was, and since it was 1959, basically I've seen eclipses over this whole set of sunspot cycles, which you see is 5 or 6 cycles. At the very right, we're all the way down at the bottom now. And when that happens, there are just a few of these streamers, and they go off to the sides. And at the poles, we can see polar plumes that look like the magnetic lines off a bar magnet, and that are hidden at the maximum of the sunspot cycle. So at different parts of the sunspot cycle, we study different things, and we get different phenomena that we can observe. But then I also want to point out that for the band of totality where you see these phenomena are only 100 miles or 200 miles wide, depending on which eclipse. But for 1,000 miles off to the sides, there are partial eclipses. The sun is still too bright to look at. You need those special partial eclipse filters. But nonetheless, for education, for outreach, the people are interested and they go outside to see it. We try to persuade them to go into totality. But still, we think there are tens of millions of people at this last American eclipse in 2017 who saw the partial phases off to the side, and they were paying attention to the sky and paying attention to astronomy and paying attention to experts talking about things we understand. So that's all very good thing to take advantage of when we can.
And here, I'm going to flip through some of your pictures. You have
a little further down, right after that big map that goes through Svalbard, there's a little more of a phase where the sun isn't quite as round, and then you can see how we break down the color of the eclipse. I know you just showed a prominence in red at the edge of the sun from hydrogen light.
So I'm now on the composite by Christian Lockwood.
Yes. Well, so here are the phases again, where the diamond ring effect is the third one up, and then when that goes away, we see the corona. And he's one of my students who we had 8 of our undergraduates at the eclipse in Oregon. And 3 of them are coming to this eclipse in a couple of months in Chile, and so it really is very good for their studies and keeps them interested and gives them a good idea of research and original research. We're very glad to work with the students on these expeditions.
And I just brought up the map of the July 2nd, 2019 eclipse path that passes through Chile and Argentina. Where will you be?
Well, I'll be in 2 places at the same time, which of course is not quite possible. But I have a group with my students and some colleagues and also a bunch of family members, and we have a tour group who are going to the center line north of La Serena. So right on the center line, not far from where those data are pointed out.
That's excellent.
But then after that was all arranged, there was a competition from the National Optical Astronomy Observatory of the United States, and I won one of 5 slots for 4 people to go to the top of the Cerro Tololo Inter-American Observatory.
Oh, man.
7,500 feet. So I can't go myself, but I have 4 people with instrumentation going there. In fact, yesterday I was busy working on the logistics and shipping equipment there, and they're supplying just a place outside. They don't want to point their big telescopes at the sun, but they're supplying an observation site and some electricity and some internet there. And so I'll be at 2,200 feet altitude, and these other 4 people will be at 7,500 feet altitude. The eclipse is low in the sky by the time it reaches South America after traversing a lot of the Pacific. So only 13 degrees above the horizon. So we're hoping for a good view. It is in the winter time. July 2nd, I point out, in Chile is the winter time. So we're hopeful, but we don't know how successful we'll be with the weather. Whereas the following eclipse in 2020 is in December 14th, which is the summertime. It goes across Chile and Argentina, and we'll be going closer to the center of the path in Argentina on that time, and that's the summertime. So we sure hope we'll be successful both times, but the odds are better in 2020 than in 2019.
And then, of course, the one that is already causing us to be on committees, or at least it's already causing me to be on committees. I don't know if you're escaping
well,
yet.
I'm on that committee too. The task force on solar eclipses of the American Astronomical Society, and a lot of the meeting that there's going to be in St. Louis in early June has to do with logistic things and traffic but we're experienced now in this country from 2017. And it was so great in 2017. We think that more people will be willing to travel into the path in 2024. And I think you skipped quickly over a slide from 2023, when there's what's called an annular eclipse, where the moon's a little smaller than average, doesn't quite cover the sun. So there's a whole ring of everyday sunlight, which keeps the sky bright. You can't see the corona, but you can make other kinds of observations. And that will go between Oregon and Texas. I see it, you put it on the screen. So if you're in totality or in annularity, you just still do need the filter, but it still is interesting to see. And if you're off to the side, seeing a partial eclipse, it doesn't matter whether in the center there's the annular eclipse or the total eclipse. So tens of millions of people in Mexico and the United States and Canada will see partial eclipses in 2023 and in 2024.
And for those of you out there watching, we will be doing trips with CosmoQuest. We are currently looking at being in Fort Worth at TCU for the 2024 eclipse. And I have to admit, San Antonio or Utah are both looking pretty good for 2023, but we haven't set our location yet. So stay tuned. You will have your opportunity to travel with us and join this community that you've gotten to know in the chat as we once again chase down an eclipse. And I promise, once again, I will stay away from the rest of you so that, as happened in 2017, everyone but me will see the totality. And I will be clouded out alone because this is my fate.
I think we're going to work on reversing your fate.
Well, it's actually... It's one of these things where in 2017 it was absolutely hilarious because I was in Carbondale and I was co-hosting on the Weather Channel with Jim Cantori, and the two of us were attached to a soundboard. And at the moment of the diamond ring effect, a expletive cloud placed itself directly over the sun, and the angle that it passed over the sun, everyone up in the bleachers was able to see some of totality. Everyone outside of the arena was able to see some of totality. And he and I saw nothing. He and I sat there with people in our ears going, "Your mics are hot, your mics are hot," while we desperately tried to figure out what to do while chained to a soundboard, unable to see totality. So I told my team all week I was very sorry I was abandoning them the day of the eclipse, but this was to protect all of them. I would be clouded, they wouldn't, and that is exactly what came to be.
Well, but now we got it out of your system, so the next one will be much better.
I hope so. I hope so.
Keep trying. It counts if you keep trying a lot. I mean, you're talking about 2024, but as we also talked, there's 2019 in Chile and Argentina, 2020 in Chile and Argentina, 2021 in the ocean off Antarctica, 2023 partial. A total eclipse clips a bit of Australia and goes into East Timor of all places. Yeah. So you have lots of chances. You just have to keep traveling and keep persisting.
Well, we'll see what happens. I'd love to get associated with a tour group in 2021. So my phone lines are open if anyone out there is listening.
Well, and I do intend to keep trying with CosmoQuest and 365 Days of Astronomy to point out when the eclipses are and what to look for. And I'm very grateful that I've been given the opportunity by you and Dr. Yamani, and it's been fun to have a chance to be on these programs.
It's been great having you across so many different years. Now, what is the next big thing that you are looking forward to, not just solar eclipse, but in astronomy in general?
Well, first of all, personally, I know about how to look at the sun, and there is a transit of Mercury across the face of the sun on November 11th.
Yes.
Which I intend to be observing from the Big Bear Solar Observatory in California. And those are very interesting things to see. And as a student laboratory, we can find out how far the sun is away by comparing our observations from the United States with observations that other people are making in Germany. We did that for the 2016 transit of Mercury. Now, of course, as I know, I have a textbook in astronomy, the Cosmos, Astronomy for the New Millennium. And I'm eagerly waiting for DHL to bring me the first copy off the printer, which was sent to me 2 days ago. But we have a lot on the discovery of gravitational waves, and the LIGO detectors with some others around the world have just gone online again. And
they've already seen 2 gravitational waves.
More, yeah. And then of course we had this whole Earth telescope finding the black hole, getting an image of the black hole reconstructed in M87, the galaxy 55 million light years away. And this is just further verification of what Eddington did at the eclipse in 1919 and showing that Einstein's general theory of relativity is correct. So astronomy is just so wonderful. There's stuff in the solar system. There's stuff on the sun itself. There's stuff in nearby stars. There's stuff 55 million light years away. But also there's a new report yesterday in the Hubble constant, the speed at which the universe is expanding.
This is the paper by Kenworthy, Solnick, and Rees. I have it sitting up on my screen waiting to be read.
Well, it's fabulous stuff, and the rate at which the universe is expanding when you actually measure it directly. And I've just actually had accepted for the physics teacher journal, a teaching journal, something about Cepheid variable stars, just for students to have a little light box to see concretely these stars that get brighter and dimmer, and you can tell how far they are away. So this group that you just mentioned has new accuracy to within 2% of the speed the universe is expanding, but it disagrees with results made from a couple of big spacecraft, the European Space Agency spacecraft called Planck, of the very early universe, just a few 100,000 years after the Big Bang. And if you look at those results and you try to use our understanding to bring them forward, they disagree on the speed.
Yeah, it's an amazing time.
Yeah, and so the conclusion that recent people made yesterday is there's probably something wrong with the physics. We need something new to explain that. We need a breakthrough, I guess, like the one that Einstein made in back 100 years ago.
Yeah, and I'm not sure if saying there's something wrong with the physics is necessarily the right way to put it, but the universe is more complicated than we thought. And there's going to be additional terms, just like when we went from Newton's theories to relativity, there's going to be additional terms on our expansion rates and that cosmology that we're looking at. And I look forward to learning those extra terms, and I'm so glad I'm no longer doing my dissertation where I had to calculate expansion rates, because it's gotten a whole lot harder than it was before we had that lambda term. So it has been a pleasure having you on, Jay. I'm going to release you to enjoy the rest of your day, but I'm hoping you'll stick around and watch at least some more of our 10-hour long stream today. Now, before you go, where can people find you and your books?
Well, I actually have a website with my books at solarcorona.com. One word, SOLARCORONA.com. And there are links to my textbook and my field guide and the book on the sun and some other things.
So we will see you later. And everyone out there watching, go check out his site, and may the sun be with you.
And the same to you. Thank you so much. Pleasure to talk to you.
Pleasure. And my computer just froze. There we go. Okay. So we are now waiting for Andy to join us. I see him waiting off in the wings of our virtual studio. And Jay, you can just click the leave button. I see you smiling there at me. I'm trying. Andy, I don't know if you can hear us. I see that you're muted. So while we wait for Andy to settle in, we are going to give you the dog cam of cuteness to thank you for the subs that I've seen come through. So I have my hand full of Cheerios. This is the best way we know to thank you. It's with cuteness. So here comes the sleepy dog cam.
There you go. Emily, can you hear me?
Yes,
Hello?
I can hear you, Andy. I can't see you yet.
You can see me. Okay, so why is the video off here? Let's see. Oh, there we go. Is that any
Okay.
better? Can you see me now?
Yeah, so I'm just trying to figure out how to get your video. There we go.
There we go.
So let
Hear
me
me okay?
switch screens around and um, as a reminder to everyone out there, if you would like to support us today, we will be recording sponsorship messages sent in by you. Either sponsor us just one day, pick your date, or become a regular patron of the show at patreon.com. $45 either way. I will record the message of your choice. Keep it clean, people. I will record the message of your choice to sponsor your favorite day of the year. Now, joining me now, pardon me a moment. I currently have it saying the prior guest. Andy, hold on.
Okay.
One moment. We literally have a guest sitting in the wings.
I've done several live broadcasts. I understand.
It's the challenge of I realized after I set everything up that my wonderful colleague in crime over here can't edit these names for me, but that's okay. She is still fabulous. She is fabulous in
The correct
many
word.
ways.
Yeah.
There. So now I have you located on screen with me. Welcome, Andy. You have been. When was the first time you produced a podcast for 365 Days of
I'm
Astronomy?
not sure if it was 2009 or 2010. It was right around that time. Maybe 2010, early 2010.
So you weren't part of our original crew, but you sure joined us early on. And over the years, you have covered so many different things. Can you give us some like highlights for you of what have been the most important moments of being part of all of this?
Oh wow! It's being able to reach out to people and to interview the people that that have all these things to tell everyone. I mean, I've interviewed moonwalkers, Nobel Prize winners, Dr. John Mather. That was quite a I'm actually right now my voice is breaking up, but just thinking about
Isn't John Mathers the nicest human on the planet?
He is, and and the first thing he said to me was, "Oh, Andy, here's my cell phone number." I was like, "You don't even know," but he's a very kind, very, I guess, down to earth is the right word to say.
Yeah. So for those of you out there who don't know, John Mathers worked on the Wilkinson microwave anisotropy probe and was one of the scientists who received the Nobel Prize for using the cosmic microwave background to start to nail down the basic properties of our universe. And he's now the principal investigator on the James Webb Space Telescope. We do not blame him for the delays. And go ahead. What were you saying, Andy?
Oh, okay. No, that was a video came back on. But well, just to name a few: moonwalkers, Alan Bean, Edgar Mitchell, and I see your video's getting switched again here, but I can keep talking if you'd like.
You shouldn't see videos. Oh, your videos may be showing a change, but the audience isn't seeing any changes.
Okay, so I'll keep.
I have you locked down on my end.
Okay, very good. That's perfect. And that's what makes this thing fun. All these kind of things. Moonwalkers, Edgar Mitchell and Alan Bean, shuttle astronauts, several, and I've been to two shuttle launches.
Wow.
But roll out, roll over, roll back, you name it, lift and mate. Been able to bring all those things to the public, things that I had no idea I would ever be able to do. My wife would say to me, "So Andy, how do you get to do all these things?" I said, I just keep pinching myself because I think I'm dreaming. Honestly, I was watching the rollover of the last space shuttle Atlantis over to the vehicle assembly building, and I was going to go home the next day. And I was speaking to somebody from Associated Press, and they said, "So you're staying for the lift and mate, aren't you?" And I was like, "Well, I got a job. I have a real job." And
we don't hold it against you.
Yeah, the one that pays the bills, and I love that one as much as I love public outreach. And he said, "Well, since 9/11, nobody gets in that building, and you're going to see the last space shuttle lifted and mated onto the boosters and the main engine." And I did, and quite a thrill to see a landing, a launches. And to actually see, I also saw the last shuttle Atlantis roll out of the vehicle assembly building towards the launch pad at night, standing like right next to it at the crawler. And then an hour later, I saw the landing of 134 Endeavour. Wow. Yeah. So to take those kind of things and bring them to everybody, it's an incredible joy and a passion of mine to do.
And what took you from someone who was interested in all of this stuff? Because a whole lot of people are interested in rockets and space. But you made that step from just being interested to actually like getting off your butt and traveling and communicating and making this part of your life. What was that process?
It's one, the first instance is very easy for me to remember. And I was sitting in my office one day. I repair medical equipment for a living.
Yeah.
There was a person who was in the residency in radiology who I'd met a few times. I'd seen him. And he walks into my office. He says, "So I hear you're interested in astronomy." I said, "Yeah, I read a lot of books and I watch these TV shows." And he says, just like this, "You're going to build a telescope." And the first thing what I thought of was, this guy is nuts. He's nuts. And I did. And it was Newtonian, of course, a Dobsonian mount, a Newtonian reflector. And I brought it to Stellafane, the big convention here in the Northeast.
Yeah.
I met John Dobson.
Oh, geez.
Who I got to be friends with and hosted him several times over just this telescope, amazing telescope that I built. Out of junk, just like John did, out of
was
the mirrors.
PVC involved?
Pardon me?
Was PVC pipe involved?
I instead of using PVC, I used a stovepipe instead. But yes, another pipe. Yes, absolutely. The toilet flanges that you use, those plastic flanges you put between the toilet and the floor.
Yeah.
Those were bearings, the side bearings.
That's awesome.
Yes, everything except the mirrors, which was the thing you really needed to make sure, perfect. So I a few months later, and I can't remember if this is 96 or 97, but there was a total eclipse of the moon, a lunar eclipse that evening, and Saturn was right next to the moon on that evening.
Oh, wow.
I don't remember that or not, 96 or 97, I can't really remember. So I'm in my yard, I'm the only person there, and I have the street I live on, the houses are like close together, or maybe quarter-acre lots, and there's only 12 houses in my neighborhood, and so on my street. So this little young girl, she goes by on her bike. She's about 10 years old. "What are you looking at?" "I'm looking at the eclipse in Saturn." She comes over and she said, "Oh, I have to tell everybody about this." So she went to every house in my neighborhood.
That's adorable.
And she's now married and going to have a child soon. This is how long ago that was.
But you still know her. You're still part of her life.
My next door neighbor, yeah. And and she lives still in Connecticut. I see her once in a while. Her parents still live next door to me. And the next thing I know, the entire neighborhood is in my front yard looking at this, and the chatter and it's been a passion of mine ever since then. Public outreach has been the power of the Dobsonian telescope and the power of public outreach. And I hope that some of our listeners, maybe someday something like this will happen to them and they could bring this wonderful, thing, astronomy to the public.
That's just so heartwarming. on so many different levels. Now, it's one thing to be outside in your driveway where you have this physical telescope that is like, "Hi, I am a telescope. Please come look through me." You can't set up a telescope without people coming over to find out what this weird thing you have set up is. But you then went on to podcast, which is one of the most ridiculously difficult things to do for astronomy because astronomy is kind of a visual field. What inspired you to make this leap and accept the challenge? And I'm so grateful that you accepted the challenge.
Oh, well, thank you. But I thank you. I never meant to say at the beginning to thank everyone from 365 Days of Astronomy, for letting me bring these things to my podcast to people. So thank you very much for all the hard work that everyone does. So I just got to the point where my wife would say to me, "So what's going on with this? Like, you keep going out there." And then I said, "Well, I feel compelled to tell everybody about this." And I joined an astronomy club. Back then it was the Astronomical Society of New Haven. And Brad Schaefer, who was
he's fabulous.
He's fabulous and wacky like me. So we made it off really well. And, he was speaking. He says, you might want to get interested. This is the Project Astro program. And I did get interested. I did go to the Astro program here with Bill and Deborah Herbst a long time ago at Wesleyan University. And I got involved in that. And then I wanted to reach more people. So then came the Solar System Ambassador program. That's when I did my first podcast, actually from this radio station before I was even a programmer here. And then a few years later, I got my own show here. And you're right. All the public speaking I've ever done, I use my hands a lot, as you can see.
Yeah.
You can't do that on the radio and explain things to people really well. There was quite a transition to make the leap, but to be able to reach so many people. And I thank you and everyone at 365 Days of Astronomy for that. Thank you.
Well, we're so glad that we've had you along on this journey across the years. And it's kind of amazing what we've accomplished. One of the things that I wasn't able to bring up in the last half hour that I'm going to pause to bring up now, because you've been part of this, is so we have our 2009 Parsec Award. We have our 2015 Communicator Award. We have our 2018 Communicator Award. And so as a community producing these podcasts, we're not just throwing audio out on the internet like so many people do. We're actually making contributions that are getting acknowledged for their quality. And thank you for being part of putting this together. Now, you do a radio show. Can you tell our audience a little bit about what you do?
Sure. Actually, I decided to pick this time frame, because I'm playing my show right now. Let's see. Yeah, it's still playing. Got about 10 more minutes left. And I thought this would be great to just use the production studio while I'm playing my show in the other studio to show everybody, like, here's where most of these podcasts start. I do my interviews here with everyone, basically via telephone. It's a very small radio station. The great part about it is we're all volunteers, and I've never taken a class in astronomy. I never had the opportunity to, even the schools I went to, the colleges. But to be able to come here, put the show together, I've been doing it since 2012, and volunteering for the station, I think, since 2011. And now, what the great part about it is that I can take the parts of my show that I do, and I can take them and make podcasts from parts of them. Now, the radio station has rights to pay royalties for music, and this is basically a music station. So my listeners like music, and I play a little music sometimes in between. Right now, I'm playing something I did with Dr. Scott Bolton from the Juno mission, and he's very into music and the relationship between science and music. And I can't play that on 365 Days of Astronomy, but I can play it here, and people can listen to it on the radio station website for another 2 weeks. So, it's a perfect marriage of, being able to do this and being able to send podcasts. And yeah,
That's just awesome.
a lot of
And
work, as you said, a lot of work.
yeah, but with a lot of work you can accomplish mighty things. And I think that's really what you've been doing, is accomplishing major things. Now, with everything that you do, you are able to integrate in the science, the tech, and the arts. What This is something new that a lot of people are, it's super trendy. I admit I paint planets, so kind of STEAM is where I live: science, technology, engineering, art, and mathematics. What got you into doing STEAM, and what do you see as the real power of this mixed media?
Yeah. Well, when I first started off with Project Astro program, you went to classes and you partnered with a teacher, and I get that part about the part that when you can communicate with the class, and we started to do some STEM things, and I found out that when kids start to do, and not just kids but everyone, but kids in particular, students in school, start to do things hands on. I tell everybody when we do this, so we're going to have fun today.
Yeah.
This is about having fun. And the kids love it. And when you get to the point where, and I'm glad that art got added to this, because I love art myself. I think it's great. And everybody has this certain way of thinking. I have a different way of thinking. I didn't do so well in grade school, or almost didn't go to college, but I was looking out the window or staring at the space thinking about some sort of science thing.
Yeah.
So I think the great thing about STEM is, and I saw that kind of leave for a while, and now it's coming back. And I get calls from schools again, and they're doing STEM programs through the PTA and other areas. And the power of going, to people and just being with them and working through these things and showing them that, hey, you can do this. This is something that is not something that someone can't do. And what's the great part about the scientific process, right? You keep trying until and then we find out all these things, and we find that we have more questions, right? So that's the great thing about science and STEM, I think.
And one of the things that I really love about 365 Days of Astronomy and working with people like you is that realization that what we do doesn't require an advanced degree. And we can go and talk to these kids that are just like, yeah, I'm never going to college. And they may have different things in their life that preclude that opportunity, but they still have the opportunity to do so much. And by putting people like you forward, who are just like, I'm doing this for fun, I'm doing this because I'm passionate, I haven't had these college classes, but look at what I've learned on my own. That is so inspirational. And you can be out there being a role model for all of these people who just want someone to acknowledge that it's possible to learn on their own and make their own path without that fancy pants, super expensive PhD that I will be paying off until I'm 65. So that's an amazing inspiration that you're being.
It is, and it's wonderful. I mean, what I tell people when they want to get interested in something like this, or even thinking about it, I said, think about having no money in your pockets, but you really feel like you do. You feel like a millionaire because you can relate to people, and you can help them, and you can show them that science and technology and all these things are fun. I mean, I wanted to be an astronaut when I was a kid. I couldn't be one, so I became an engineer, right? And it's been a wonderful profession. And what's wrong with not being an astronaut? There's plenty of things: art, science, technology, and with computers and what we have on the internet today, there's such great opportunities. We used to have to go to, I have two kids. They're 11 years apart. They're adults now.
Yeah.
One of them, I bought an encyclopedia for. The second one, she said to me, don't buy me an encyclopedia. I can get everything I need on the web, So the opportunities are there for us. And this is a great time in the golden age of astronomy, golden age of space travel, and the golden age of public outreach, I hope.
I really think it is. And as we see Congress cutting the budget for NASA education, as we see so many other things happening, It's the work of volunteers that is really going to be, well, who goes out and keeps the kids learning science. So what is the next big topic you're looking to take on?
Wow. Well, I've had some ideas of, I've never done a Google Hangout, and I thought of doing a Google Hangout and a radio show, a live radio show at the same time. But I thought that might be a little much, but it's tough enough to do one or the other live. I need a couple of people helping me.
Yeah.
But basically what I wanted to really do is reach more people.
Yeah.
And so I think of different ways to do it. And I thought that would be maybe the next step. But the more I can get, to me, it's the more I can learn about these things and the more I could tell everybody else about them. And of course, the Solar System Ambassador Program, which I still belong to, teaches me all about these great subjects. And to be able to, to talk to Mark Raymond and find out that he found out that about ion propulsion from a Star Trek movie, and now he used it in a mission,
Yeah.
So more public outreach and reaching more people, I hope.
That sounds awesome. So if people want to go find your stuff other than 365, where all can they find your stuff?
Yeah, well, the radio station is wpkn.org. And of course, my monthly show is on there and a little bit about me. There's also a link to my website, which has almost all of my podcasts on it and interviews. And that's liftoff, lift-off.us.
And that liftoff is really one of the best ways to find you, and is how I always find you on the internet when I want to check up. So this is fabulous. And what is on your tie? I can't decide if it's a star or if it's a Mars crater.
Oh, it's just stars in the background. It looks like M37. I don't know. Is it?
That's awesome.
But I wear these. What's really cool is I wear a tie to work too, and I wear all these different ties. And people say, "Oh, yeah," and they get interested. And I get people, as I walk into work, say, "I can't." It takes me like 20 minutes sometimes. I get all these questions, which I love. I get the phone calls. The image of the black hole. It's on its way. It's coming. It's coming. I said, "Yeah, it's coming. It's coming."
And Cosmic Lettuce out in the chat responded, "M37, my favorite open cluster woot."
Oh yeah, it's a cool one. Yeah. So. The more we can do this, the more, the better it is for everyone. And the difficulty, I think, in one thing is that astronomy can't be taught in school. Most classes, most grades don't teach it, but we can help teach it. And even when it's taught, it doesn't get the broad sense that we can bring it to people with, So that part of it, I think. The other thing is the history. Here we are, 50 years Apollo. I don't know if I'm taking too much of your time, but
No, you're good.
Okay. So, 50 years of Apollo. If you talk to someone in school, did you learn about the Apollo program in history? No. Why isn't it American history?
History never gets past World War II. Occasionally you'll get as far as Vietnam and Nixon and Martin Luther King, but Apollo, even though it happened at the same time, somehow just keeps getting left out because it wasn't seen as a cultural change. Although you talk to people who remember that period in history, and it was a huge influence on their identity.
Yeah. I think maybe part of it was a very tough times in this country in those years, war and all those things that were going on. And I think that might've been it. But at the same time, it is part of American history, and I think it should be taught in textbooks.
Yeah, and hopefully that is the future that we're aiming for someday in the not too distant future. At least this is what I hope. So, I'm so proud to have had you as part of what we've done for all these decades. Now, with everything that you've done, do you still find the time somehow to get out on that sidewalk and inspire, I guess, your neighbor's grandkid now, almost soon?
Yeah, I do, but not as much as I'd like, because doing a pre-recorded show once a month is it's written by me, produced by me, edited, engineered, the whole bit. I write the script, so that takes a lot of time. But
Yeah.
I still love getting out once in a while. And there's an area I live near the shoreline here in Stratford, and there's a public area at the seawall. And I'll go down there once in a while, bring the telescope. And I also, there's another place where this area called the Lordship Improvement Association owns this property that just looks out over the sound. So there's no light pollution for quite a few miles if you're looking and it's perfectly placed, southeast. So I do a public viewing there a few times a year. I try to get out and do some myself because that's really the part that really gets to you sometimes too. I mean, this is public outreach, great, but I would recommend for anyone to look through a telescope on their own sometime. You'll feel like you actually discovered what you just saw.
And are you still using a telescope that you built yourself?
Yes, and I've helped other people build them. And I had a friend who had an idea, and we changed the idea to get him and we built this telescope on my kitchen counter, and then he made 300 or so with school kids and adults. We did them through museums. He did most of them with them. And I scratched up our new kitchen counter. I didn't tell my wife. And then my friend kept saying, you're actually going to see this big scratch on the kitchen counter. Put the telescope on the counter. And I said, we're just not going to say anything. She never noticed it.
That works. That works. Well, everyone out there watching, we have, I want to say, dozens of episodes with Liftoff and with Andy, all on 365 Days of Astronomy. You can find them in our back catalog, and you can keep finding him as new episodes come out week after week. Thank you so much for being here. I can see our next guest waiting in the wings. So I am going to flip through everything.
Thank you so much for letting me be a part of 365 Days of Astronomy, and everyone that helps. There's a whole lot of people in the background, just like with us, here. Everyone that helps, would greatly appreciate it.
Thank you so much, Andy. And have a fabulous rest of your Saturday. And may your studio be quiet and your skies be dark.
Same to you. Clear skies.
Bye-bye. So